Thank you very much, Dr. Kang. It's a pleasure to begin this symposium. I've been asked to speak about the pathophysiology of photoaging and as well some of the manifestations of photoaging. So on the left is a picture of an individual who went to Aruba, and this is one single sunburn. On the back, this is a 23-year-old person. You can see where the bathing suit was, and you can see in this great illustration the profound damage that can be brought, most probably due to mutations, multiple mutations in many cell types, melanocytes, no doubt keratinocytes, which this individual will carry forever because it's very, very likely that many of these are in the stem cells. So this is what happens after a single severe sunburn. In chronic sun exposure, you have a picture that looks like this, where you have brown spots, you have wrinkles. The wrinkles are of the coarse sort, and this is a fairly good example here, but I chose this mainly to show the brown spots, because the brown spots are one of the major targets of retinoid treatment. Now, although sun causes major damage in terms of immunosuppression, mutations, certain kinds of skin cancer, the focus of my discussion today is going to be on the connective tissue, in other words, the extracellular matrix that brings these types of changes after long-term sun exposure. The left-hand side of this individual's face is worse than the right hand. This is part of a study of several hundred patients where we showed that the side that is exposed to the window when you drive has the majority of the sun damage, and people in other parts of the world have found it to be on the other side of the face when they drive on the other side of the road. So it's very, very likely, the far and away the most likely environmental insult would be sunlight. So how does this come about? That's really the subject of my talk today. Here's an ordinary histology slide, and the epidermis being extremely thin, in the order of 1/10 of a millimeter, you can read newsprint through it, cannot be the source of these wrinkles. It is certainly the source of various kinds of cancer, but not the wrinkling. And so it's our belief that the major molecule participating here is collagen, and there are many kinds of collagen, but 90% of the mass of the dermis is type 1 collagen, and the other major collagen is collagen 3. I'm only going to talk about collagen 1 today because collagen 3 tracks in terms of its regulation and changes identically with collagen 1. So you can just assume that they're both the same. We do have the data, we have done it, and that is the way it is. So this eosinophilic, I guess on this slide it's more bluish, but on a non-PowerPoint presentation, you know that it's eosinophilic when you see it in a microscope, and it's responsible for the form and the strength and the function of skin. So this is the major focus of our work. We're aware that elastin is there, but for a variety of reasons that I will go into if you want during the discussion, I can tell you why I don't think elastin is a key part of what we're talking about. Elastin is important to elastosis, the yellowish nodular changes and so forth, but remember, what I'm talking about here is the genesis of wrinkling. So collagen per se is not that easy to measure. So the vast majority of individuals, ourselves included, measure procollagen. We measure that in various ways. We have a number of techniques that I'll show you. And then collagen, once it's formed, is degraded into collagen fragments. First taken down by collagenase into 2 fragments, 3/4 of the length of this molecule and 1/4, those 2 fragments. And then gelatinase will work on those fragments and take it down to very small pieces. And so one can measure the downregulation of collagen by either collagenase assays or gelatinase, and there are various ways of doing that, from activity to gene expression, protein content, etc. And then, of course, we can measure collagen fragments, and once you see collagen fragments, you know that you've had the activity of these 2 enzymes. Now, the point of departure of our work has been really an axiom that you'll have to agree with, otherwise you might as well go out and expose yourself to the sun. Incidentally, it's a great thing that you're here, because about 5 minutes we have shown in our early work, 5 minutes of the kind of sun that's outside today will absolutely, definitely kick off all the biochemistry that I will talk about a little later.